Section 4D moves us into loans. Roman numeral 1 is about loan basics. The definition of principal is the amount of money owed. Installment loans or amortized loans, also known as amortizations, are loans that you pay off with regular payments. Our formula to find the regular payments is payment equals principal times APR over n being the number of times you make the payment in a year, all divided by 1 minus the quantity 1 plus APR over n raised to the negative n times y, and then close your bracket. And I'm going to hurry and just show us how to write that in there for your benefit. Those of you who are familiar with this process, go ahead and skip forward for just a little bit on your video. But I'm going to go ahead and insert an equation just so that you're familiar when you're turning in your own homework on the homework supplements. Payment equals, I'm going to come up to my fraction and using my over arrow button, P times, and I want brackets, parentheses, and inside here I need another set of fractions, over arrow button, to give me APR over n, and then using my down arrow I need another set of brackets, and in this case I'm going to use these brackets over 1 minus, I need another set of parentheses, over once, 1 plus APR, oops, I needed that to be in a fraction, so I'm going to highlight that and put it in a fraction, down arrow, n, over, and again I need to highlight this and say I want this to have a superscript, or raising it to the power of negative n times y. There we go. So now that you have it typed into your Word documents, when you turn this in, I'm going to get rid of this so that my notes all work out, and that makes it bigger. When you get this all typed in on your homework supplement, if you ever want to use it, or in a test, now you can just copy and paste it instead of typing it in over and over. Our first example is, let's suppose we're borrowing $12,000 and we have an APR of 12%. We're going to make monthly payments for 6 months and pay $200 towards the principal. So the first thing we need to find out is how much interest we're accruing on the principal. So this one I am accruing 12%, but this 12% is just like we did with our APR when we did an investment. We take our 12% or 0.12 over, and this is monthly payments, so 12. Just like we have up here, APR over n, and times this by my principal. So I'm going to copy this. You can go ahead and use your calculator, but because I want to show you, I have some things already pre-canned for later, so I'm just going to type that into some cell. There we go, $12. Okay, coming back, this is equal to $12. Payment to principal, we were told that we're going to make monthly payments of for 6 months of $200. So now my total payment will be the payment towards my principal and the interest. So the payment here is $212. Now the payment to the principal is how much I'm paying towards the principal here. If I'm paying $200, my new principal is $1,000. And that $12 here isn't subtracted because I'm being charged that interest, so I have to pay that $12. Now my prior principal for month 2 is $1,000, and I'm going to take this same idea, my interest divided by 12, so 0.12 divided by 12 months, but in this case I'm going to times it by $1,000, which gives me $10. So you can do that in your calculator. Again, I'm only making $200 towards my principal, but my total payment to the bank is $210, and that other $10 just goes to the bank for saying thank you for letting me borrow money. And my new principal, subtract, gives me 800. And then we come down here to my new principal is 800. And 0.12 divided by 12, in this case times 800, gives me $8. Again, $200. In fact, let's just go ahead and fill that in the whole way down. Oops, I'll go back and fix that. Okay, and then my payment here is $208, but only 200 comes off of my principal, so this is now $600. And my new prior principal is 600. 0.12 over 12 times, in this case, $600 gives me $4. So my new payment is $204 and my new principal is $400. Then I bring that same down here. You're probably seeing the pattern over and over now. Times this by the new principal, which equals $2. So my new payment is $202, and I only take off $200 because this is the payment on the principal. The $2 goes towards the bank for paying them for the loan. My new prior principal is $200. And some of you are thinking, well, that should just come off at $200, right? But remember, I'm still being charged this interest. And this one is two. Did I get off somewhere? Oh, I did. This should be 6. Pardon me, 6. For those of you who were typing it into your calculator, you were probably getting it right and confused about where I was going. So now my new payment here is 202. This should be 204. This should be 206. All right, now that that's better, and then we pay $200 towards the principal. That $2 goes towards the bank, and since there's only 200 left, we've now paid it off. So one of the benefits about doing Excel is we wouldn't have had the problem that I just did because it's just going to copy and paste exactly what I've typed in. So I'm going to go into Microsoft Excel where I've already got us set up just a little bit. Month 1, 2, we said we were going to do 6 months. Since I set up a pattern, I'm going to just grab that and pull it down. The principal we're starting at is $1,200. Now on this one, to make it calculate like a calculator instead of going back and forth, I'm going to press equals, and I know I have an interest of 12%, so I can actually cell reference this or type in 12 or 0.12. And because I'm just going to cell reference because I already typed in 12, and this is always going to be the interest, I'm going to press F4 to make it an absolute cell reference, divided by 12, and then times this by my prior principal. This prior principal is going to change like we did in the other one. It went down, so I don't want to absolute cell reference that one. Just reference it, and we get $12. There we go. Now this is always going to be 200, so I'm just going to take this and pull it down so it's always 200. So that was faster than what we did in typing it in. And our payment that we have to pay towards the bank will be those two cells added, or we can write sum and then highlight the cells. Either way, it works. And I didn't need to absolute cell reference those because on the next months, the interest is going to change because the principal will change. If I click outside here, again, you'll notice that it referenced that cell and I didn't want that in there. So make sure if you want to get out of this, press enter. Okay, new principal. That's going to be my prior principal subtracting the payment of 200, which gives me my new principal of 1,000. And my prior principal will be this one. Now the interest, let's go in here and see what I did for my formula. This one I did an absolute cell reference of my APR divided by 12, and I referenced the cell to the left. So that's good. I can go ahead and pull this down and double check. Yep, it came along with me to the C5, or the cell next to me. 200 is still there. The total payment, that was when we added the two cells to the left, so this will just add the two cells to the left. That's good. And the principal will be, again, let's double check that. We didn't do any absolute cell references. This cell minus this cell, which should go ahead and copy down nicely. Good. So far, everything's looking good. It matched exactly what we did by hand. But now the nice part is I can highlight this whole row and drag it down to the very end. Uh-oh, it seems like we have a mistake somewhere. Where did I get off? Usually I would turn off my recording, but I want to kind of troubleshoot this with you. What did I do here that made something go, there we go. This started picking up and adding one in Excel instead of taking it just as 200. So I'm going to re-pull that down. There we go. A little troubleshooting. Now I know that it came down to 0. Now everything matches. And that was a lot faster fix than what we did earlier when I got off on my 6. And I had to change 1, 2, 3, 4, 5, 6 different cells. In this one, I just had to find where the mistake occurred and pull it down. And then if you were doing something like this on your homework, you could highlight all of this, right-click and press copy, go back into your Word document. Aha, there's my note that says try it with Excel, and press Control V, or right-click and press paste, and you're done. I'm going to go ahead and get rid of that because it's going to move my notes around. Okay, so now that we tried it with Excel, we've noticed that that was so much nicer. Let's move on to the next problem. Oh, notice how our payments change. It started out at 212 and then 210, 208, 206, 204, and 202, which gets kind of confusing. If you were really a bank doing this, or making these payments, it's kind of weird. You want to know exactly what to expect every month. So that's where our formula comes in handy, which we have up here. And again, I remember how we said we could just, once we have it in, right click, copy and paste, which I've done. And I'm just going to bring it down, copy and paste so that you can see me fill it in. So the principal in this one, we started out at $1,200 for the principal. The APR was 12%, so I'm going to put 0.12. And we were making monthly payments, so 12. And I just have to change this one again, 0.12 for the APR, 12 for the monthly payments. Up here we have 12 for the monthly payments, and press times so that we know that the N and the Y are two separate things. And this was only for 6 months. So I'm going to put 0.5 for half a year. And we can copy and paste this into Microsoft Excel, or you can go ahead and use your graphing calculator. Press equals, Control V, and remember there's one thing that Microsoft Excel doesn't like when we do this, and that's these brackets. So I'm going to switch those out for parentheses. And again, I need to put a time sign here because it doesn't recognize that it needs to do anything in between those. However, you and your graphing calculator will know how to do that. Press equals. It looks like everything's good. There we go. And I'm going to format this as currency and then copy, come back into my document, press Control V to paste, and there's my answer, which I have down here. Since I have that once, let's go ahead and get rid of it. So if I wanted to have equal payments every single time, I can use my payment formula, and instead of having this adjusting, and I'm going to highlight this in some fashion to be the answer. All right. This is something that you need to know. You will be asked this on some homework or a test, or at some other point. You'll need to know how to find the interest from some principal and then subtracting. You'll also be doing this on your amortization spreadsheet for project, I don't remember what project number, but for one of your projects, the amortization project, and then you'll subtract to find the new principal. And I want to quickly address one thing in here. The reason we didn't just highlight this row and move down is there was nothing referencing for my prior principal. And as you can see, Microsoft Excel thought that was adding one. Oh, when we highlighted all of this and pulled it down, it thought it saw a pattern and it changed this to $12,001. So you need to reference this over, but everything else was just fine. And then we can highlight and pull. And this one, if we wanted to prevent the mistake that occurred earlier, we could say payment of $200, and instead of typing in 200, we could absolute cell reference this, and it wouldn't pick up on any sort of pattern occurring like we did with the months, which we did like the pattern occurring. In this one, though, it wasn't as good. Okay, let's move on to the next example. Let's suppose you have a student loan of $7,500 with an APR of 9%, and the loan is for 10 years. How much will your monthly payment be? How much will you pay overall? And how much will you pay in total interest? Now, I've had some people get confused on total interest versus the interest that you're paying per month. Remember, this is just on a prior principal for just that month. This will be the overall through the whole life of the loan. How much did you pay in interest? So let's go through kind of what we need to do here. The monthly payment, we've already talked about the formula, so I'm going to bring it down here. Type in all of the information. The principal was $7,500. The APR is 0.09 over monthly payments, and it tells us they're monthly, so divide it by 12. And then we have again 0.09 over 12, make my n again 12, and years in this case will be 10 years. And I've shown it here. You can copy and paste it into Microsoft Excel, or I'm actually just going to show you the other trick with Excel. Copy, come into Excel, and just so I can see my information, I'm going to paste it in here and press equals PMT. There you go. It'll calculate your payment for you. My rate is 9% divided by 12, comma, the number of periods will be 12 times a year times 10 years, and you'll notice that it says years after here. So I'm going to have to come back in and delete that because it's not going to recognize that to be something that I can calculate. PV is present value, 7,500. My future value will be 0, or I can leave it. These brackets, those are optionals, so you don't have to put it in. It'll calculate it either way. So I could leave it, or I can type it in. Either direction. Now it's going to say value because that right there needs to be a number instead of words. There we go. And you'll notice it's a red number saying that that is money away from me or in the negative. And I'm okay with that because this is a payment of $95.01. Let's go back in. And there we go, $95.01. So how much are we going to pay over the entire life of the loan? If I'm paying $95.01 every single month for 10 years, I need to take this $95 times it by 12 months a year times 10 years. There we go. So I can even do that in here. Equals this times 12 times 10 years. 12 months a year times 10 years gives me 11,400. 11,400. You'll notice this is rounded compared to this one. That's because in Microsoft Excel, even though we're only seeing to the nearest penny, it does keep in its memory many more decimals, so this is actually more accurate and this one's rounded. Either way, I'm okay with the answer. And when you turn in your homework or your um, tests, and it might be nice to say this is the more exact answer coming from Excel versus just rounding it, or tell me I rounded this to the nearest penny and I took this instead of just using Excel. Now let's figure out the total interest paid. If we paid $11,400 over the entire span of the loan, but the loan was only $7,500 to begin with, then the money beyond that was money in interest. So I'm going to take the total that I paid in the whole loan, subtract how much it was to begin with, and I'm left with what money came out being paid in interest the whole time, which was $3,900. And again, I could have done that in here, equals. Now notice this is a negative number, so instead of subtracting, I'm going to add the 7,500 so that my numbers work out, which was 3,900. Or I could have changed that to a positive number by making this a negative out in front. And then in this one, instead of adding, I would have subtracted. Just as long as you keep those positive and negatives when you're working with the Excel functions. All right, let's go back. Our next example, C, is principal and interest on payments. Kind of looks familiar. We've done a little bit of this before. Calculate the portion of your payments that go to principal and the portion that goes to interest during the first 3 months from the above example. So I would take very close attention to this example right here. I guess that was kind of a hint, wasn't it? So we want to calculate the portion that goes towards interest from the payment. So my payment, we already found using our formula right here of $95.01. Now notice I've rounded mine and it's not using Excel to go beyond the 1 penny. How much money of that is going to go towards my interest? So I need to figure out how much interest is coming off of the first month. So I have 7,500 and times that by 0.09 divided by 12. So the APR over N times my principal, and I'm going to go ahead and copy and paste this into Microsoft Excel. If you have a calculator, go ahead and use that as well. Equals, Control V. Oh, it already has an equal sign, so I'm going to get rid of one of those. There we go, $56. So this is 56, was it $56? Right on. Okay, now that I have how much money I pay in interest for the month, I can subtract that from my total payment of $95.01 minus 56. $95, oops, I forgot my equal sign, equals 95, subtract my money here, gives me $39 left of what's not being paid towards the principal. So this is what I could, or from the interest, so this is what I can take off from the principal. So my new principal is going to be what I started with, 75,000, and subtract, oops, I got an extra zero in there, minus the 39. There we go. So now my next month, my interest will change. So I'm going to press equals. The APR is still the same, but now it's a little bit less. I'm going to go ahead and go to my notes instead of going back to Excel over and over. So my new principal is going to be 74.61 and 24 cents. Yep. Oh, these were rounding in Excel. Let's come back up here and format these to round out to the nearest penny, so 2 decimal places. That feels better. 38.75. So this is 38.75. 38.75, and it's actually $56.25. So that's one thing. I'm not editing this lesson as much because I think you need to see some of those things occur, what sort of problems you could experience in Microsoft Excel. All right, so now that I have my new principal, I'm going to put that down here with my interest being times by $77,461.24, which will equal, I can copy and paste this into Excel, or I can use your calculator, and it ends up being $55.96. I sure like Excel. It makes a lot of this calculation go a lot quicker. Okay, but my payment is still $95.01. So what is left over after my $55.96 going towards interest will be $39.05, which means my new principal, I'm going to take the 74.61 and 24 cents and subtract the $39.05, which makes my new principal $7,422.19. Then my next month, and we kind of did this up here in my prior example, so I'm not going to go through it as much. If you need to see it again, I'd rewind the video until you can get back to example A. And 0.09 divided by 12 times my principal over here is $74,022.19. Copy and paste. So now and calculate that in your calculator, or we can copy and paste that into Microsoft Excel. So it can calculate it like a calculator, and then you don't even have to make sure that you didn't get your decimals off. Oh, that's a percent. We have to go format that cell to be a currency. And once again, we need to make a currency go out to 2 decimal places. So in this case, it should be $55.67. Good. Okay, 55. Oh, I didn't copy that. Copy and paste. There we go. And now I have still the $95.01, but $55.67 is going towards interest. After you subtract that, you should be left with $39.34 going towards principal. You'll notice that this is going up just a little bit, which means I'm not paying quite as much in interest because the principal is going down, and that means I can start paying more towards the principal. So then I take my prior interest, 74.22.19, subtract the 39.34, which will give me a new principal of $7,382.85. All right. However, like we've just discussed, this is going to be much faster with Microsoft Excel. So let's go see. It doesn't look like I have this one in here, so we can go ahead and set it up. Let's come over. We started out with 7,500. We have an APR of 9%. We're only going to go out 3 months, and we know that we'll write 3 months just for us. So I'm going to write, I need the month here. The next cell over, we want to know how much is going towards interest. Then we want to see how much is left for principal. And then we have a new principal. So we have month 1, 2, 3. The interest is going to be equal to 9%, again, F4 to make it an absolute cell reference, divided by 12 for the monthly payment, and times it by the principal, which gives me how much is being spent on interest. Oh, and I need to add in one more cell, so I'm going to insert here because I need the prior interest, or the prior principal. And I'm not going to finish typing that out for principal. Okay, so how much is left for principal? My payment, oh, that was one thing we didn't do. The payment was $95.01. So how much is being left over for the principal? I'm going to select my principal and press F4 to absolute cell reference it, subtract how much is going off in interest, and I'm left with $38.76. So my new principal will be, in this case, I can cell reference here or here. Since I did my previous cell reference for the interest to this one, I'm going to go ahead and keep it. Subtract how much goes towards the principal, because everything else went towards the interest of the $95. There we go. And because that's my new principal, I'm going to reference it to here. And in this case, I referenced my interest, or my principal over here, so I can't pull it and drag it down. Oh, what'd I do? Divided by, 12. Okay, so I'm going to have to redo my formula here. Equals, I'm going to absolute cell reference here, my APR divided by 12 times, now I have my cell next to me. And then I'm going to have whatever's left over, absolute cell reference, my $95, subtract what money is going towards the interest, and everything left over will be principal. The new principal will be this old principal, subtract what money goes towards the principal, and I need to reference my new principal here, but then I can highlight these 3 cells, pull them down, and we're good to go. Let's see if this matches. $77,382.85. Yep, there we go. So we did it right, and that one was a little easier. It may have been easier had we done a cell reference to here like we did in this example, but it worked out just fine. And then if you were turning this in, copy and paste, put it into your document. All right, let's move to the next one, an auto loan. This auto loan is for $6,000, and we're going to compare 3 different loans. We could do a 3-year loan at 8%, a 4-year loan at 9%, a 5-year loan at 10%, or a 5-year loan at 10%. So the first thing we want to do is find the monthly payment for each of the options, and then we're going to just compare the total interest paid at the end of the 3 years, so 4 years and the 5 years, and just see which one ends up being the better deal. So we have option 1, option 2, and option 3. Again, we have our payment formula. We'll type in principal of $6,000. APR is 8%. Monthly payments, so 12. APR 8%, monthly payments 12. And 12 months a year for, in this first option, is 3 years. So Y is going to be 3. Copy and paste that into Microsoft Excel, or we could also use our new payment formula. So we could do, just so that I know what so I know what all the information is. It was a $6,000 loan. It was for 3 years, and it was at 8%. So equals PMT, parenthesis, I need the rate 8% over 12, comma, n per number of periods. So I need 12 times 3 years, comma. The present value is $6,000. I can leave the future value or I can put in 0, it doesn't matter, which gives me a payment of $188.02. Oh, and I've already prompted you what you can put into Excel. Now, how much am I going to pay on interest for the whole life of the loan? If it's $188.02 every single month for 3 years, I need to take that 188 times it by how many months are in a year, 12, times the full 3 years, which gives me $6,768.72. But the loan was only for $6,000, so everything else we paid on top of that was the interest. So subtracting gives you $788.02. That's how much we paid on interest for the whole loan, not just how much was paid per month. I guess I've said that twice now. So I would take note of that because it might come up at some point. All right, so the next one, we can go ahead and take the exact same thing. So copy and paste and then just change your APR and the years to 4. Plug it into Microsoft Excel by copying and pasting, or you can use your payment just like this and change it to, in this case, 9.09 over 12, and then 12 times 4 because option 2 is for 4 years. The loan is still for $6,000 and you'll get $149.31. Again, how much we need to pay or is paid overall. We take how much our payment is times 12 times 4 years gives me $7,166.88. That's how much we pay for the entire loan over the whole 4 years. But the loan was for $6,000, so subtracting gives me $1,166.88. So we end up paying quite a bit more in interest by extending it an extra year, but you'll notice my monthly payment is much smaller. Okay, not much, but it is quite a bit smaller. Let's try the third option. Any ideas? If we had smaller payments for option 2, but ended up paying more interest overall, and in essence paying more for the overall payment or the whole loan, any ideas what you think will happen on year 5? 5 years at 10%. 10%? All right, let's try it. So we copy and paste the payment formula. $6,000. In this case, I have to change the APR to 10%. I need to change it down here to 10%. And it's for 5 years. Or you can put it into Microsoft Excel just like this. But in our case, for this one, we would do 10% over 12. 12 times 5 years and $6,000 in Microsoft Excel. And oh, I don't have it in here, so let's go find it. Oh, I did. $127. So our payment went down even more. And I'm going to highlight in some fashion for that to be the answer. $149 down to $127. So the monthly payment has gone down significantly from almost $190 to just over $127. But let's find out how much we pay in interest. So we have $127.48 times 12 times 5 years. I'm going to copy and paste this, and I've copied my equal sign. So I don't need to put an equal sign in there. I can just press Control V. Oh, and it says a dollar sign actually means something different in Microsoft Excel. So delete that. There we go. 7,000, and I'm going to format that to be currency. Copy it and paste it back into here. Okay, and let's line it back up for my sake. So we end up paying $7,000 in total, but I want to know how much I pay in just interest. So I need to subtract $6,000. So come back into Excel and equals this cell, subtract $6,000 gives me 1,600. So I'm going to copy this in, equals Control V. Oh, need to bring that over just lined up for my sake. All right. So let's look at these options again. Option 1 was for 3 years at 8%, which means I had a higher monthly payment. But in the end, I only paid $700 in interest. Versus the third option, I had a much smaller monthly payment, but I ended up paying over $1,500, and I'm going to highlight that, over $1,500 in interest. So it's a significant difference between the two. And that's exactly what they do in loans. If you want a smaller monthly payment, you end up paying more over the full time of the loan. I like to compare this to the gospel really quickly. You can choose an instant gratification, which would be a smaller loan or a smaller monthly payment, but in the end, you pay more. So, versus credit cards versus saving money and paying what you can afford versus ending up having to pay more in the end. President Ezra Taft Benson in the 1979 New Era said, "Truth is truth, whether it's labeled science or religion. If you have a shorter loan, there's less total interest but higher payments. Just like you can have something now and sacrifice your eternal happiness, or a longer loan, the more total interest but you have lower payments." So I like to make that little comparison. Let's move on to credit cards. Let's suppose you have a credit card of $2,300 already accrued with an APR of 21%. You decided you want to pay it off in 1 year, so what would your monthly payment be? So we take our payment formula. The principal is 2,300, APR is 21%, divided by number of payments per year. In this case, it's told us monthly payments. Again, 0.21 over 12, N is 12, and the Y, we want to pay it off in 1 year. Copy and paste, go into Excel, equals Control V. Now the reason I'm showing you this, some of you are thinking I'm just going to go in and do the payment formula every time, but it's nice for me when you're typing in things into your Microsoft or into your Word document such as this so that I know that you know the formula. It's nice to leave that there and then you just copy and paste it in. So there's several different ways. Then copy and paste your answer back in, $214.16. So that's what your monthly payment would be for you to pay off this $2,300 in 1 year. All right, let's suppose that you have a credit card debt and you lose your job. So you called the credit card company and they have allowed you to suspend your payments. You have a $9,500 debt with an APR of 21% and it's compounded daily. Ouch. So they suspend your payments for a while until you find a job. But while you're waiting, they continue to charge you interest. It takes you 1 full year to find your job, and then you start making payments towards the credit card debt. How much is your new balance at the end of the 1 year, and how much interest did you accrue in that 1 year without paying anything? Now they didn't, you didn't have to pay anything on it, so that was kind of them, but you're still going to accrue interest. So we're going to go ahead and go back to our formula. A equals P times the quantity 1 plus APR over N to the NY. So our principal in this case is going to be the $9,500. 1 plus APR is 0.21. N, in this case, we're compounding daily. 365 days in a year, raised to the n times y, which is 365 times, it took us 1 year to find, so times 1. Copy and paste that into Excel, or use your calculator, will give you $11,719.23. Okay, but that's at the end of the 1 year, and that started your principal. And the question was, how much new interest did you accrue after that year? So if it started out at 9,500, if I subtract that, I have $2,219 at the end of 1 year just by letting that $9,000 sit in this account. Let's go ahead and see what would happen. I'm going to use the same information, 9,500, 21% compounded daily, and use our future value function in Excel just to show you another trick. So I'm going to come in here. I can use the formula, or I can do future value. Parenthesis, it's asking for the rate. Our credit card was 21%, and divided by, we had 365 days a year. 365 days for the number of periods times 1 year, or I could just leave it, but it's a good habit to get into. The payment was 0. We didn't make any payments, and our present value was $9,500. Press equals. There we go. 11,719. There's our answer. Let's move to Roman numeral 3 on mortgages. You'll be doing a whole mortgage spreadsheet for our finance section as one of your Excel projects. So this is kind of your heads up on it. A down payment is the lump sum of money, usually about 10 to 20% of the house price, that goes towards the payment of the house right up front. Then during this negotiation, you also have closing costs. These are the lender's fees. There's two different types. A direct fee is a fixed dollar amount, such as just saying $2,000 as soon as everything goes through. There's also points. This is a percent of the loan. Each point is worth 1% of the loan. So if it was $2,000 loan, now I know it's a mortgage, so we're just going to say 2,000. You take 0.01 times it by the 2,000, and that's how you find your how much you pay for closing costs when you have points. Prepayment penalties. There are some institutions that if you pay off the loan early, they will pay or charge you penalties for it. Then there's the fixed rate mortgage, and this is when the APR doesn't change throughout the lifetime of the loan. Even though APRs are changing constantly, it will stay the same from the very first moment that you start your mortgage. So let's go with our home loan of $100,000. You find a 30-year mortgage for 8%, and you want to compare it to a 15-year mortgage that has a slightly less APR of 7.5%. Let's go ahead and compare the monthly payments and the total interest paid on the two loans. And I'm going to highlight this so that we know that's the 30-year loan, and this is the 15-year loan. So we can copy and paste our payments down from our formula above, or we can go in and use Microsoft Excel and use payment. Fortunately, though, we've already done this one, and from the previous example, let's just copy and paste this into Excel. Copy, paste, equals, Control V, and give us a multiplication sign, and delete and put in parentheses. Oops, and it looks like I copied a little bit more than I should have. There we go, $733.76. There we go. And so we want to find the interest paid. We've done that before. We take how much our monthly payment is, times it by the months in a year, and times it by how many years, times it by 12 times 30, gives us $264,153.60. Now that's what we pay for the entire loan, but the loan payment or the loan principal was only for $100,000, which means over 30 years, we pay more than 1.5 times what the original house loan was. Let's go to the 15-year and see if that's any better. So this one was a 7.5%. We can come in here and copy and paste it, or in this case, we can do PMT just to show that we know lots of different ways. 0.075 divide by monthly payments, comma, 12 times, this one was a 15-year loan with a present value of 100,000. Press enter, $927. Oh, let's go ahead and copy and paste that. Copy and Control V to paste it in. And let's move this over just to line everything up again. And highlight this in some fashion to be the answer. There we go. Now to find how much we pay in interest overall, we do our, let's just Control V that in again because it's still stored. And times that by 12 months a year times, in this case, oh, that should be 15 years. And let's come into here, equals this times 12 times 15 years is 166,000, copy this, $862. Control V. Now I need to subtract the original loan, which was 100,000, and that'll tell me how much interest was paid through the entire loan. So I'm going to press equals. Now notice this is still negative like before. So if I'm going to subtract 100,000 from this, I can't really subtract because subtract a negative makes it more negative. So I'm going to add 100,000. Now I could have changed this to be positive by putting in a negative and then subtracting. Either way, you'll still get 66,000. Go back into here, Control V, and highlight that as the answer. A rather dramatic change between those. $164,000 versus only $66,000. We changed it by only paying for half the amount of time, but my monthly payment is a much bigger payment, about $200 more every single month. Okay, let's go to the next one. We're going to compare two banks, Great Bank versus Big Bank. We have a $100,000 loan offer, and Great Bank has a 30-year fixed mortgage of 8%, and it has closing costs of $500 plus 2 points. Big Bank has a 30-year fixed mortgage of 7.9% and a closing cost of $1,000 plus 2 points. So I pay $500 more in closing costs, but I do have a slightly smaller APR. Let's compare those and see which one ends up being the better deal. So I need to figure out, the first thing is the payment. And oh, we just found this one. So $733.76, which is the exact same as what we did in the first example. So we copy and paste, or you can do Microsoft Excel again. And then in this one, I change it to 0.079. It's still a 30-year mortgage with monthly payments, 30 years divided by 12. In this case, my monthly payment's a little bit smaller. It's $726 versus the $733. It doesn't sound like much, but over a span of 30 years, it's going to make a big difference. So I need to figure out the total cost by multiplying my monthly payment times 12 times 30. Take both of those, and I get $264,153.60. And in this one, I get $261,651.60. So it ends up being, oh, about a little less than $3,000 difference. But remember, we have closing costs. The first one had a closing cost of $500 added to 2 points. So 2 points means 2% or 0.02 times the original loan amount, which is $100,000. 100,000 times 0.02 gives me $2,000, and the 500 points gives me closing costs of $2,500. Then Big Bank has very similar closing costs. 2 points or 2% times 100,000 is $2,000 plus $1,000 gives me a closing cost of $300. So which one really ends up being the better deal? Even though we spend $500 more with Big Bank, it ends up being cheaper because in the end, if I were to add these up or subtract, I have 2,600 or 264,000, subtract my 261,000, it's cheaper by $2,502. But that was for the cost. The closing cost was $500 more. So if I take away what it was get ahead by, then it's really only $2,000. Overall, it's cheaper by $2,000. Another way of thinking about it is taking these numbers and saying, I have 264,000. So let's bring it into here. Equals this, and I'm going to take out the dollar sign, add it to the 2,500 for the closing costs. Oh, I left in a, oh, they took out my comma. Good. All right. So that's what it costs overall at, I think it was Great Bank. So if I want to come in here to Big Bank and copy and paste it into here and take out my comma and dollar sign, add in $3,000. Now I can look at these and just find the difference. Equals this minus this total gives me $2,000 and $2,002 that it's cheaper by, even though it does have a higher closing cost. So that's something else to keep in mind, is that closing costs can sometimes change what it is overall. Let's go into another offer. This is just Great Bank and it has two different offers for closing costs. The first offer is for a $100,000 loan, is 30 years with a fixed APR of 8%, and it has 2 points. The other offer is another $100,000 loan, a 30-year fixed APR of 7.5, but in this case it's 4 points for the closing cost. So let's compare these. It's very similar to the previous problem. The first offer, to find the payment, we can use our payment formula, or we can use Microsoft Excel. And let's go ahead and come in here, let's clean some of this out. Equals, we have $100,000, oh, payment, PMT. The rate was 0.08 over 12. We have the number of periods, 12 months in a year times 30 years. The present value is 100,000. Future value we're going to assume is, of course, 0. And so my payment is over here, $733.76. I can come in again and do another one, or I can just change this by 7, I think it was 7.9. Oh, 7.5. Change that to 0.075. There we go, $699.21, which we have here. To find how much we pay total, we do our $699.21 times 12 times 30, which gives us a total of everything we're paying in this loan, $251,715.60. The total over here, $264,153.60. But we also need to take into account the closing costs. With a 7.5%, we have 4 points, or 4% of the $100,000. 0.04 times 100,000 gives me $4,000 in closing costs. The 2 points for the 8% gives me 2% of $100,000, or $2,000 in closing costs. If I add these together, so I add the total for how much I pay for the loan and add in the total for the closing costs, I get for, I put this as the first offer. So I have these a little backwards. First offer, and this will be the second offer. Then this ends up being $255,715.60. Adding my closing costs and the total here, I end up with $266,153.60. So I do have to pay a little bit more upfront, but at the end of 30 years, by taking this option, I end up paying a lot less. Now, when will I end up making up the difference between these two? So I have $4,000 in closing costs and $2,000 over here. By what point does it end up changing that I actually make up for the $2,000 more in my closing costs? Because we do know overall it is cheaper to go with this option versus this one. But that's over the whole life of the loan. What if you've decided that you're not going to stay or own this particular house for the full 30 years? So when will it end up being a better option? Well, let's figure out the difference between our monthly payments. So we have $733.76, subtract $699.21, means I end up paying $34.55 more every month. If I divide my $2,000 by my $34.55 per month, I end up with 57.9 months that I'm paying this extra $34. Using our unit conversions, 1 year over 12 months, and I can cancel out months, and I'm left with years, it's at 4.8 years. That's when I finally make up that $2,000 difference. So if I wanted to go with this offer, with only with the less expensive closing cost, if I own this home for less than 4.8 years, I don't make up the difference, and it would actually be cheaper to go with the smaller closing costs versus this one. If I own it for longer than 4.8 years, it ends up being cheaper to take this option. Let's move to payment strategies. Roman numeral 4. Right here is a display of how, or a graph of how the interest versus the principal of our payment ends up going throughout the full 30 years. So right here is 100% of my payment. This portion of the payment, in this first payment, I only end up paying a little less than 10% of the whole payment going towards principal. The rest of that is all interest. And I pay off just a little bit more every month, just a teeny bit more, until we start getting down here, and then it finally starts picking up and we end up paying most of the principal every month until it's all principal and no more interest, and then the payment is the loan comes to an end. So the more we end up paying at the beginning, the more we'll save. If I paid just a little bit more here in the blue, then the next pink and blue will have more blue here because I have less interest than I'm paying on the previous, and so forth. So the more I pay at the beginning, the more I'll end up decreasing it over and over for the next month. All right, so we have a 30-year 8%, and we want to change it to a 15-year, which means we have larger payments, just like we talked about here if I paid a little bit more. So I'm changing it from a 30-year to a 15-year, and it will make larger payments, but overall, we will have less interest paid. So I'm going to take my $100,000 loan, and I have an 8% APR over N, which is 12. 1 minus the quantity 1 plus APR of 8% over 12 raised to 12, and in this case, 15 years versus our previous example of 30 years at 8%. We have 30 years at 8% right here. So this was my payment of $733.76. Changing it to a 15-year loan makes my payment $955.65. You can do that with your calculator, or again, copy and paste this into Excel, or use Excel and we'll type in PMT in Excel. It'll prompt you for the APR 0.08. It will not prompt you to divide by 12. You must do that on your own. And every time you type that in, because ours are going to be amortized with our payments, they're either amortized or the other one with the investments, you're making monthly payments. So it'll always be divided by 12 or whatever these compounds are. Then number of periods 12 times, in this case 15 years, and then it'll ask for the present value, and we have $100,000, and I'm not going to put a comma in there because it won't accept that into Excel. We don't have to put the future value, and it'll give us our payment of $955, which ends up being $221 more per month because we had a $733 payment and 76 cents from the previous example. So it ends up being a little bit more. If we decided to take the 30-year loan and go ahead and treat it like a 15-year loan, that means you're paying just a little over $200 more than your statement in the mail tells you you need to pay, and you can change your 30-year loan into a 15-year loan. It cuts your loan time in half by just tacking on $200 more every month. But there are things that happen in life. Maybe you lose a job. So sometimes it's nicer to take the 30-year loan just in case something's going to happen, but treat it like a 15-year loan and just tack in the extra $221, and you cut the time in half for the entire loan. Okay, Roman numeral 5, the adjustable rate mortgage, also known as an ARM. This means that your APR increases if the rates increase while you have your loan and you have your loan at a 6% APR, the bank will end up losing money because they could have loaned that same money to somebody else at 8%. So if you have your 6%, what they've done is they said, we'll have an adjustable rate mortgage. So that means that the APR will fluctuate with the prevailing rates of the day. It can be capped at 10, and sometimes it's great. If you end up getting into your house with a mortgage with a really high APR and suddenly the market goes down, then you just fall with it. Other people end up having to refinance, which means they go through the whole loan process again and end up getting a lower APR, which works, and then they can keep that. The unfortunate part is sometimes you get it at a low APR and then the market goes up and you end up having to pay much more than what you originally started out at. Usually they'll leave you a loan for about 6 months to a year. You'll have something low and then it'll start going with the prevailing rates. So let's compare these two mortgages here. We have a 30-year fixed mortgage at 8% versus an adjustable rate mortgage, and we're going to the first year it's at 5%, and then in the fourth year it's raised to 11%. So let's see what happens in these first couple of years. And it really depends on whichever one you want, uh, because sometimes you aren't going to be there for very long. Maybe you're going to buy a home and only stay there for 3 years. So this fourth year won't affect you. So let's go with the 30 year. The first year we have $100,000 times our APR is about $8,000 of going to interest. Then the other one, $100,000 times the ARM, which is 5%, you only pay $5,000. So you save $3,000 over 12 months that first year. So if I divide that by 12, it means I save $250 a month in savings if I go with the adjustable rate mortgage. But when the fourth year occurs, my, this should be an 8. The fixed rate mortgage is 8%. So it's still $8,000. And it's kind of nice to know that that's what you should expect every time. In the fourth year with the adjustable rate, you have 11%, which is $11,000, which means you end up spending $3,000 more than the fixed rate mortgage. Divide that by 12 and you end up spending or paying $250 more every month. But it really depends on what's going on. It's kind of like a gambling game about which one, and it so depends on your own personal situation. In the long run, I would say the fixed APR is better simply because you can go ahead and refinance if the rates drop. But sometimes the adjustable rate, sometimes it'll work better for your situation. And that is the end of 4D. I hope you join me on our next section, and good luck on your 2 Microsoft Excel projects.